Electric current is the directional flow of electrons, as we discussed of it before. The directional flow of electrons, or ions. Metals are good conductors. Good conductors of electricity because the delocalized valence electrons are free to move. Have you written delocalized electrons enough? Do you remember that metals have delocalized electrons now? Okay. Solid ionic compounds have valence electrons that are held solidly in place. They have that stronger hold there. Therefore, they cannot conduct electricity. When ionic compounds melt or dissolve in water, then it gets exciting. Okay? So if we dissolve it into water, the ions are able to move past one another. Which allows them to carry an electric current. In most molecular compounds, valence electrons are not free to move through the molecule, therefore they are not able to conduct electricity. And if we melt molecular compounds, so if we melt or dissolve in water, they're not made of ions, so it's not going to work either. So if we melt or dissolve in water, they do not form ions, and therefore they do not carry an electric current. Now, I didn't write, we just have a couple more notes. I didn't put them in your thing, but just follow along here for a moment. So basically we've gone through several different types of bonds, and then we still have to do covalent network. So I'll just skip here for a second. Okay, so covalent network. So write this below your notes. We'll go through this here. So covalent network. So it is a network of covalent bonds, and it forms a crystal. So it's different than the ionic crystals, but it does form that crystal. And these, this would be like our diamond, okay? Because a diamond is an ionic compound. It's a covalent one. It is a 3D arrangement of atoms continuously linked. Throughout the crystal by strong covalent bonds. So this would be like the definition for covalent network, so that would be an important one to memorize. Okay. And yeah, so that 3D arrangement in a crystal formed by covalent bonds. And that's not so bad as covalent network. So think, okay, well it has to have covalent bonds, and it's a network, okay? They're very hard, very high melting point. So if we say it's a very high melting point, this means strong intermolecular bonding, okay? So this network of covalent bonds is very strong. And they're non-conducting because it's covalent. Okay? Okay, so if we are able to get like an X-ray diffraction of crystals, we see a pattern like this. And so it's showing a lot of networking between the bond, or the molecules. So then if you took that picture and kind of made like a computer image of it, this is what it would look like. So this is like an example of a diamond and how it's networked. And now it's not like showing like carbon this, blah, 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 but each corner, just kind of how I showed you here, how I drew the carbons, okay? Each corner is a carbon atom. So it's very strong, like you can look at it, you just look at something like that, you're like, yeah, it's pretty strong, right? Yeah. Okay. So that's what covalent network looks like. So now in summary, so we've talked about the covalent network. You don't have to write this down if you don't want to. But so we just talked about covalent network. We've also talked about our ionic bonds. We know what those are like. Cations plus anions. Their forces are ionic, hard and brittle. Medium to high melting point, liquid and solution conductors. Molecular is made of course, molecules. And then we have, because of that, we look at our forces, our London dispersion, dipole-dipole, and hydrogen bonding. They're generally soft, low melting point, and non-conducting solid. And then we talked about our metallic bonds today. So this is the cations with the C of D localized electrons, resulting in a high-density metal. Its forces are just the metallic bonds, soft to very hard, and solid and a liquid conductor. Okay, so this is just, that is just a little summary of what we've been talking about. Okay, so do you need to memorize exactly what each of these things is like? No, but if you think to yourself, okay, what are ionic compounds? Well, they're made of ions. So if I free up those ions, now the electrons can flow, so it's a conductor. And you know, you guys have been, you should have been kind of experimenting since junior high. Okay, salt in water, conductor. Sugar in water, not conductor. Well, sugar is a molecular compound, salt is not. It's ionic. Right? Yeah. Am I losing you? No? Okay.